Okay, so this is in your workbook, so let's take a look at it. It looks really pretty. The limit as x approaches 4. Notice there's no plus or minus up here, so that's a two-handed limit of f of x. The whole thing is f of x. Nobody's labeled it anywhere as f of x, but the whole thing is f of x. This is an unconnected graph. They've got vertical asymptotes all over the place, but it's all one thing. Okay, it's all f of x. So y equals f of x should have been somewhere, but that's okay. So as x approaches negative 4, what's happening to f of x? Well, as I'm approaching 4 from the right, the limit doesn't exist. It's going off to positive infinity. And as I approach it from the left, the limit also doesn't exist. It's approaching positive infinity. The answer to this, people, in my class is does not exist. But you can, since both directions are going off to positive infinity, we can hold on to that information, which is going to be important. But in reality, the limit doesn't exist because it's not going to a real number. Okay, so in my class, that does not exist. The limit as x approaches negative 3. Well, that's kind of cool, but this throws people off for some reason. They really get upset with this question. As I'm approaching from the right of negative 3, I'm approaching negative 2. And as I'm approaching from the left of negative 3, I'm still approaching negative 2. So my little Silver Surfer guy, no matter which way I'm approaching this value from, we're always approaching negative 2. Guys, it's a no-brainer. It's just negative 2. Okay? So don't make life too difficult for yourself. That's approaching negative 2. The limit as x approaches 2 in this case. All right, well, there's 2. So as I approach from the left, you'll notice that the limit does not exist. So as soon as I see that, I know that the two-sided limit does not exist. And as I approach from the left, it's taking off to negative infinity. And as I approach from the right, it's taking off to positive infinity. But that I shouldn't write anything here. If you really wanted to, and you wanted to give people a heads up, you could say this. As x approaches 2 from the left, y is approaching negative infinity. And we used to call that end behavior when it was at the end of the graph. Because this is the middle of the graph, we would call it middle behavior, I guess. But it's the behavior near the asymptote, is what we'd say. This is actually the behavior that's happening near this vertical asymptote line. Maybe if I scale out a little bit, I can see it better. Here's my vertical asymptote line, and it's what's happening as I get close on this side. And as as x approaches 2 from the right, y is approaching positive infinity. So if you wanted to, and I don't see any reason why you wouldn't, you could tell me this, but ladies and gentlemen, the limit does not exist. That's the ultimate. Don't you dare tell me, in this class that the limit as x approaches negative 4 of f of x equals positive infinity. If I see that, that's wrong. It does not exist, but goes to positive infinity. Okay. Over here, the limit as x approaches 4 now. So there's 4. This is a two-sided limit. So as I approach from the left, I see that I'm approaching 1. And as I approach from the right, I see I'm not approaching 1. That's a problem. Does not exist. The limit values are not the same, so that limit doesn't exist. This is a whole bunch of grade 11 questions. So f of 4 is going to be 1. F of negative 1 is going to be 0. F of negative 4 is undefined. And the last one, the limit as f of x as x approaches 5 from the right, this way. So Silver Surfer guy gets on top, starts sliding down, and he's approaching 2. Notice, if he ever gets to 5, he's going to fall through the hole and end up here, but that's another story. That's not a limit. Okay, I'll pause the video there.